Hello students, welcome you all in this next video, and here we are going to solve 4-mark question from section B chemistry. Already I have completed section A biology and I have uploaded the video. You can go through my channel, watch my videos, and still if you are not subscribed, please consider subscribing my channel. So now we are going to start with section B chemistry, and from this section we are going to solve 4-mark question in this video. So let's start with the question. So as I told, we are going to solve 4-mark question. So here we have only one question in 4-mark, that is question number 28. To see it is little bit big, but just you have to read this statement carefully, then it will be easy to answer all the questions. So Sara took 2 ml of dilute NaOH. So Sara, she has took one test tube, and in that she has took 2 ml of dilute NaOH solution. What is NaOH? NaOH is a base, sodium hydroxide, so it is a basic solution. She has took basic solution 2 ml in a test tube and added 2 drops of phenolphthalein solution to it. What is this phenolphthalein? It is an indicator, which is a type of acid base indicator. So the indicator which is used to find the given solution is acid or base by changing its color. Such type of indicators are called acid base indicator. And phenolphthalein is one of the common acid base indicator which gives pink color in base and remains colorless in acid. So what she did, she took basic solution 2 ml in a test tube and added 2 drops of phenolphthalein. So as I told, it is added in base, it should give pink color. So the solution turned pink in color. She added dilute H2SO4 to the above solution. Now the solution is already pink in color because of the base, and now she is adding H2SO4 to this solution drop by drop. When you add acid to the base, it neutralizes the base. Acid will neutralize the base and try to decrease its basic properties. So now what happens? When this is added drop by drop until the solution in the test tube becomes colorless. So once you add this H2SO4 drop by drop, the basic property will be go on decreasing, and therefore pink color will become light and light, and at some stage the pink color will goes and the whole solution becomes colorless. Now what is the meaning of this? All this acid which are added, it has neutralized this base and forms salt. Now 40 drops of dilute H2SO4 were used for the change in color from pink to colorless. So here, as I told, H2SO4 is added drop by drop. How many drops were required? 40 drops of H2SO4 required to neutralize this 2 ml of NaOH. Now next, when Sara added a drop of NaOH to this solution, now see, it was 2 ml of NaOH, we added 40 drops of H2SO4, it got neutralized. Now it is colorless. And now Sara will add a drop of NaOH again, and now the color will be, now it is becomes basic, and now the color will again change back to pink. Sara now tried the activity with different volumes of NaOH and recorded the observation in the table given below. Now she did the same activity by using different volumes of NaOH. In the statement she has used 2 ml, but by changing this volume of NaOH she did the same activity, and whatever reading she got, that all she has recorded into this table. So you can see, first she took 2 ml and drops of H2SO4 required 20. Then she took 3 ml NaOH, drops of H2SO4 used 30. She took 4 ml NaOH, drops of H2SO4 required 40. So remember, NaOH is in ml and H2SO4 is in drops. This you have to remember. Now answer the following question based on the above information. So by using this activity and using this table, you have to answer the given questions. Question number A is, if Sara used concentrated H2SO4 in place of dilute H2SO4, how many drops will be required for the change in color to be observed? So here you can see, first she took 2 ml of NaOH and she added dilute H2SO4 drop by drop, and the color became pink to colorless because you are adding acid. But this acid is dilute. Dilute means what? There is a water in this. So because of the presence of water in this H2SO4, H plus ions will be less in a dilute H2SO4. I hope you're understanding. Whenever we say dilute, the H plus concentration will be less because of the addition of water. And these H plus are responsible to change the color from pink to colorless. Because it is dilute, it has less H plus, and therefore it gets 40 drops to change the color from pink to colorless. But in the question they are saying it is concentrated. If we add concentrated H2SO4, so concentrated means what? H plus ions will be more. If H plus ions increase, automatically the change in color will take place soon, easily or faster, and you required less amount of H2SO4. If you compare the H plus ion in dilute H2SO4 and concentrated, more amount of H plus ions will be there in the concentrated, and H plus ions are responsible to change in the color. If you add concentrated, then very easily in less drops color will change, and that's why the option you can see here, A is 40, B it is less than 40, C more than 40, and then you have to justify your answer. So what is the answer? We require less than 40 drops, because for dilute H2SO4 we require 40 drops. In concentrated we have more H plus, and therefore we require less than 40 drops of H2SO4. Now what is the justification? Same thing which I have explained. Concentrated H2SO4 contains higher amount of acid per drop compared to dilute H2SO4. Therefore, fewer drops of concentrated acid are needed to neutralize same amount of NaOH. Here they have not changed the amount of NaOH. An amount of NaOH is same, that is 2 ml. Only we are changing concentrated H2SO4 in place of dilute, and therefore as a result the pink color of a phenolphthalein will turn colorless in less than 40 drops. So this is the justification of this question A. So I hope you understood this question, that is A. After this we will move with B. Now we will see question B. Sara measured 20 drops of dilute H2SO4 and found its volume to be 1 ml. So Sara has measured 20 drops of dilute H2SO4 and she calculated in ml, so it became 1 ml. If Sara observed a change in color of NaOH solution by using 3 ml of H2SO4, how many ml of NaOH did she added to the test tube initially? So if 20 drops of H2SO4 is nothing but 1 ml, then NaOH solution by using 3 ml of H2SO4, how many ml of NaOH did she added to the tube initially? So this is the question. What is the answer for this? 20 drops of dilute H2SO4 means how much? She measured 1 ml. Therefore, 1 drop is equals to how much ml? If 20 drops is 1 ml, then 1 drop is how much? So if you cross multiply, for 1 drop, it will be 1 by 20 ml. I hope you are understanding this. So 1 by 20 means how much if you calculate? If you divide 1 by 20, it is 0.05 ml. So this will be in ml for 1 drop. So remember, 20 drops means 1 ml, then 1 drop means 0.05 ml. Now, in the question, Sara used 3 ml of H2SO4 to neutralize NaOH solution. We need to find the volume of NaOH solution initially added. So, how much NaOH was added initially, that we have to find out. So, by using this, now we will start. So, we will start solve in steps. So, 1. Determine the number of drops in 3 ml H2SO4. So, first we will determine the number of drops, because this everything is given in terms of drops. So, first we will find out how many drops are there in 3 ml of H2SO4. So, number of drops is equals to volume divided by volume per drop. Total volume divided by volume per drop. So what is the volume of H2SO4? It is 3 ml. So I took here 3. And volume per drop means single drop means how much volume? 0.05. So we divided it. Once you divide 3 by 0.05, we will get an answer 60 drops. So in 3 ml, how many drops will form? 60 drops will be formed. So 60 drops of H2SO4 neutralize the NaOH. We have converted our 3 ml of H2SO4 into drops, and we have got the answer 60 drops. If you ask me to do this calculation, how we have divided 3 by 0.05, that also I can do it here. So see here, 3 ml divided by 0.05 ml per drop. You should remember or you should understand how to solve this whenever the numbers will be there in decimal. So what you have to do, it will be easy, the calculation will be easy if you remove this decimal. So remove this decimal and you have to, while removing, you have to send this decimal to the two places. So from 1, 2, the decimal should come here. So how many times you have moved this? 2 times. 1, 2. Therefore, we have to multiply 100 on the numerator and therefore it becomes 3 into 100. Why 100? Because we have moved our decimal to the second place here. 1, 2. Therefore, we have to multiply by 100, but it will be on the numerator. And down, now it will be only 5 because we have removed the decimal. Once the decimal comes here, there will be no meaning of this. It will be like 5.00. 5.00 is nothing but 5 only. Therefore, 5. Now see what happens. It will become 300 divided by 5. And now it is easy to divide. 5 ones are 5. 5 6 are 30. 5 zeros are 0. And we got our answer 60. So this is the 60 drops which we got. Now here we have converted our 3 ml of H2SO4 into drops. Now we will do the second step. So see the second step from the question. Now see what is the question. Sara added 2 ml of NaOH solution initially. Initially Sara has added 2 ml of NaOH and it took 40 drops of dilute H2SO4. We have seen in the question. Sara, she has added 2 ml of NaOH and to neutralize that we took 40 drops of H2SO4. This gives us a ratio of H2SO4 to NaOH. So what we can do? We can do like this. H2SO4 drops is to NaOH ml. So what is the ratio? H2SO4 drops how many? 40. And ml how much we took? 2. So 40 is to 2. 40 is to 2. 40 drops for 2 ml. Then 20 drops for 1 ml we can write. So therefore it can be 20 is to 1. Now the third step. Now she used 3 ml of H2SO4 which is 60 drops. See here, she has used 3 ml of H2SO4 which is 60 drops. Let the initial volume of NaOH be VML because we don't know the volume. We have to find out this V. So again use the ratio H2SO4 drops divided by volume of NaOH. So what is the H2SO4 drop? 20 from the earlier, see here, 20. You can take 40 also, but we have used this one, 20. And what is the volume here in ml? It is 1. So 20 divided by 1. Now, what is our given values? 3 ml, 60 drops. So I took 60 drops divided by, we don't know the ml, so therefore I wrote here V for NaOH. And this is the given, which is here. And now if you compare these two, so 60 divided by V, it is nothing but 20 divided by 1. Now what we can do? We can do cross multiplication. What will happen? 60 is equals to 20V. Now shift this V on this side. So it will become 60 divided by 20 is equals to V. And now if you divide 21s are 20, 23s are 60. So V will be is equals to 3 ml. And this is the answer. So here I have written V is equals to 3 ml. So initial NaOH solution added is 3 ml. And this is the answer for this question B. I hope you understood this answer. Try to understand each and every step. Here what I have done, I have divided this whole sum into 3 steps. Step 1, step 2 and step 3. It is little bit tough to solve, little bit confused, but try to solve it step by step. It will be easy. So this is the answer for question B. Now after this we are going to see the next one. In this question B we have an option, or there is one more, we have C. So we can either you solve B or you can solve C. Now after this we are going to solve with the next option, that is C. Now the question is, that is or, Sara takes 10 drops of dilute H2SO4 in the test tube. Now she is going to take 10 drops of dilute H2SO4. So remember, it is dilute, means it has less H plus, but it is an acid. Drops of H2SO4 in a test tube and adds drop by drop phenolphthalein indicator or solution to it. So phenolphthalein is an acid base indicator. She is going to add drop by drop into this H2SO4. Now remember, H2SO4 is acid and you are adding this indicator. So what color it should give? It should remain colorless. Now we are going to answer this all. Then she adds NaOH dropwise. Sara observed a change in color after adding 20 drops of NaOH. What change in color would she observe and why? So very simple. Sara's solution initially turns colorless because it is acid, and in acid phenolphthalein will be always colorless. So you have to remember one thing. So remember this, whenever there will be acid, if you add phenolphthalein, it will be colorless. This is the main thing which you have to remember and which is already there in the textbook, and already I have uploaded the video of this chapter, that is acid, base and salts. You can go through my channel and observe this whole chapter I have uploaded, and in detail I have explained this everything. So in acid, if you add phenolphthalein, it will be colorless. In base, if you add phenolphthalein, it will be pink color. So this you have to remember first. If you know this, then you can answer such type of any question if it is coming in the exam. So this you have to remember. So make a note of this in your book. Now come to the answer. Sara's solution initially turns colorless because initially it is H2SO4 acid, and in acid if you add indicator it will be colorless, therefore colorless. In acidic H2SO4, as she adds NaOH drop by drop, so slowly one by one drop, if you add NaOH, this NaOH goes and neutralizes this H2SO4. So what this NaOH is doing? The acidic property, it is decreasing slowly. It gradually neutralizes the acid, and after 20 drops, immediately it will not change the color because it is slowly neutralizing. After 20 drops, the solution becomes slightly basic. Why slightly basic? Because all H2SO4, all H plus have been neutralized, and now the solution is basic because of NaOH, extra NaOH. And if it is basic, what color it should give? It should give pink. So causing phenolphthalein to turn pink. This color change happens because phenolphthalein is colorless in acid and pink in base. This is the reason. So here I have explained answer and why. The reason of this is here in the last sentence. So this is the answer for this OR question. So I hope you understood this answer. Now this was the OR for question B. Now we will see the next option, that is C. Now here C we will see C option, which is very easy. Write a balanced chemical equation for the reaction taking place in the above experiment. Which of the following is true and why the reaction is? So here they have given 4 statements. You have to see which statement is true for the above reaction. So the statements are neutralization and double displacement, neutralization and precipitation, precipitation and double displacement, neutralization, double displacement as well as precipitation. So here first we will write the reaction of this. So you can see the reaction, we are using H2SO4 and NaOH. So it is acid, it is base. See what happens now. So if I take here H2SO4 and if I add this in NaOH, neutralization reaction takes place because acid will neutralize the base and base will neutralize the acid. So here hydrogen is positive ion, sulfate is a negative ion, Na is positive, OH is negative. OH means hydroxide. So positive of this will combine with the negative of this, negative of this will combine with the positive of this. So what we are going to get? We are going to get Na2SO4. And why this Na2SO4? This everything is already we have studied in the 9th standard. Depending on the oxidation state, we have to write this formula. So Na2SO4, and we are going to get water, because when this H and this OH combines, we'll get water. We have to whole reaction we have to balance. So Na2 means here there should be 2, and to balance what hydrogen we have to take it here 2. And in such way we are going to get this chemical equation. So it should be balanced, because in the question they have asked balanced chemical equation. So you have to write like this. Now this is salt and this is water. Whenever acid base react to give salt and water, such type of reactions are called neutralization reaction. So here it is clear that the reaction is neutralization. In the product, if you see, water is the water medium, and salt, sodium sulfate, it is aqueous salt. It can be easily dissolved in the water. It will not form any precipitate. So here there will be no precipitation. So second statement will go wrong. There will be no precipitation. Even the D will go wrong. There will be no precipitation. Then we have to check in A and C. C again having precipitation, so this will be wrong. So correct option is what? A. So in A they have told neutralization double displacement. What is double displacement? Displacement means changing the place. Double means all the ions will change the place. Positive of this, negative of this, positive of this, negative of this. Everything, all the places will change. That is called double. So here the reaction is neutralization and double displacement. So you can see the H plus which was here, it is going this side, and the Na which was here, it is coming this side. So all positive cation, anions will change the place. Therefore it is double displacement. For example, I am telling here, see, it is Fe, and if it is CuSO4, now what happens? See, only Fe will go on the other side and Cu will come out. So only one place will be changed. So it is a single displacement reaction. But if such thing happens, it is called as double displacement reaction. So the reason is acid reacts with base to form a salt and water, which is called neutralization, and involves cation and anion exchange. So it is called as double displacement, and there will be no precipitate formation. Precipitate means solid, PPT, solid formation. So there will be no solid formation, and therefore the correct option is here option A, and this is the reason for this question. So I hope you will understand all the answers I have explained very neatly and completely. Make a note of these all the answers. After this, we are going to solve with 5-mark question. If you like my videos, please consider subscribing my channel and share my videos with your friends.